Welcome. It's a good crowd here this morning. I'm glad you're all interested in little tips and tricks. Hopefully I catch a few that you don't know about already. VTScada is a big product. Just by its sheer nature, SCADA systems are complex. They have lots of features because there are lots of different varieties of things that you might encounter. So over the years, 32 years, lots of things get put in the product and we talk about the big features, but sometimes some of the really useful features get lost in the noise and don't get taught in training courses. Some of them do and are forgotten about. So hopefully I'll hit on a few things that you'll find pretty useful. That'll make your day-to-day work more productive. So this one you probably already know about, but I'll go through a couple of things already just in case you kind of have forgotten about it. But I'll just throw it up on taskbar management because a few people sometimes are caught, oh, I forgot about that. Little buttons on the taskbar. If I go and choose a display to view, I can then pin it to the taskbar. Let me go pick a different one that's not already there. So you navigate to your page. There's a little pin icon here. If you hit the pin, it freezes it on the taskbar. A couple of things that are in addition to that. If you start to run out of space on your horizontal taskbar, a little set of arrows appear on the right that allow you to slide the number or the buttons over so you can read more buttons if you start to pile too many on the bottom of your screen. There's also a little X here, which doesn't immediately delete that, but it removes it from being pinned. Pinned means that it's going to stay there when you switch to a different screen. So I switched over to a different page. If that All Stations button stays there. You can also decide that this is not in the right place. I can just click, hold, and drag across and put it in the right slot on my page. All of these buttons on the bottom are set up per user so that each user in the system that's logged on will get their own set of task buttons at the bottom so that when you log in as a different user, different operator, you get your own personalized buttons. The last thing that's a quick tip is that although you can hover over it, if you right click using the right mouse button on one of these buttons, it'll open a pop-up window view of that page. So that's pretty useful if you have multi-monitors. Right-click on them, drag this over to a different monitor and keep it there for a while. So I suspect most of you knew about that kind of feature, but I'll throw it out because it's a quick starting point. The operator's tile view is one that is there, but it's there's a few little differences there that might be able to take advantage of. So let's take a look at this view. This is your normal navigation pages that you can use. You got your choice of little text list or this tile view, which are active pages. So you get to see the live view of what's going on each individual page before you navigate to that page. Now this view here is of a sub-menu. Now say you wanted to actually have an operational view where you see all 4 pages at the same time live, like we see here. But there's a lot of clutter on this view here because we have at the top the recent pages and some descriptors down there, page names. So if we take that and make it more of an operational type page, I can go to my menus. I pick page menu, and I have this industry demo application here. If I choose the properties on that, there are a couple of extra checkboxes on here. Again, I'll read them off so those who can't see can actually make some sense of it. There's a hide recent pages, that's the top piece on the screen here. These pieces towards the top of the page. Hide labels and hide the folder path. That's here. To make more room, When I say OK on that, you see what happens to the background. This tile view now becomes more of a 4-page operational system that actually has 4 functional pages on it, which I can now pin to the taskbar. So if I go flip from a different page, go back to this, I actually have an operator view that could show any set of pages I want in a grid. It doesn't have to be 4 pages. Could be 2, could be 6, but it's a way to have an overview of your system and a single page that's quickly navigatable. And if I want to go into details, of course, I just click on one of those pages and it takes me to that actual page in full screen. So that's been there for quite a while. And I have to say, I don't think I've seen too many places that actually have implemented that or used that feature in their plant operations, but it's a neat thing you can do really quickly. Incremental ChangeSets. Now we get a little more technical here. As you're probably aware, VTScada supports this concept called ChangeSets. They're accessed through this application configuration tool, which can be accessed from the top of the toolbar if you have configuration privileges in your application. And if I do a create ChangeSet file, that's on the left-hand bar there, 4th one down. This create a standard ChangeSet file creates a file which contains all of the configuration and all of the history of configuration for your application. And this is perfect for distributing your configuration to a system integrator or tech support. It gives you the full backup of everything that has ever happened in your application. So I'm going to step down here to show version log, which shows a list of all the changes that have been made on this application. And that's what's in the change set. All of these list of changes over time are all chronologically recorded in the what we call the repository in VTScada. Great tool, I'm sure you're aware of it. The change set captures that and rolls them all into a single file. So I create that change set file, and I'm going to call it VTScadaFest Thursday. I know you can't read that. It writes all those changes out to this single file. And here's our file that was created. And I'll let you know that that says 18 megabytes. So that 18 megabytes isn't too bad. But when you're in a real production system, that 18 megabytes often ends up to be something in the range of 300, 400, 500 megabytes, even higher. Because you've got a big system, it's recording many changes over many years. So that file can get fairly large. So the point of this feature that I'm going to point out is the incremental change set. So I'm going to make a small change to this application just to create something that's subtle change. We changed the color, small issue. We created a new version in the repository. Now, if I wanted to send that change out to tech support or system integrators, think, well, that's going to be another 18 megabytes I have to send out to someone, or 100 megabytes that I have to send to someone. If I can't attach that to an email, it's too big. I've got to do some file transfer or something that's a little more awkward. So what there is in this incremental change set is a way to take a snapshot of your current state. So you call this button here called Make Revision File. So I'm going to make a revision file here. VTScadaFest Revision, it's called. I'll save it. And the idea is that when you send someone, or you saying, I'm the system integrator, or I'm tech support, I want you to send me your latest changes. I, as the system integrator or the tech support person, will snapshot a revision file that gets the state of what my version of your system looks like to me. So I've got this revision file, And it is really tiny. I can send it to you in an email. As a matter of fact, it's only 474 bytes. Sometimes it's bigger, it's a few K, but it's a small file, easy to send off to the customer, the big system. And meanwhile, the customer has made many changes to the system. Like I'm going to go back and say, I've made some further changes to this. Something that shows up better on the projector. Change the color again. Now the color's changed. So on the system, changes have been made, probably more dramatic than just changing the color. And the system integrator wants an update to your system. They sent you this snapshot revision file. So this revision file has come in, and now at the site, you have this checkbox on creating the change set. It says, limit change set history to revision from, and I can select the file. It's already been selected for my rehearsal here that says VTScadaFest revision. So it's going to use that revision file that I received to say, I only want changes since that snapshot that the system integrator had. So I'm going to make this change set. I'm going to call it Thursday 2. Now you can see the difference. Thursday was an 18 megabyte file. If I just get the incremental changes, the change set file now is just only the changes that have happened since the last revision file that was made. So that, in this case, is only 860 bytes. So the difference between 18 megabytes and 860 bytes. Now, obviously, it's going to be bigger numbers than that, but the changes are on that kind of scale. I can either send you the whole 500 megabytes of change set, or if I send you the revision file of what I already have, you only have to send me perhaps 100K or something that I can attach to an email. Things go a lot faster. So it's a little bit of procedure there, as always in VTScada. F1 brings up help on how to do it. So it's all there, but the important thing to know is that it's there and there's a way to do it fairly simply. Follow the instructions. You'll save a lot of time, a lot of headache of just transferring files by FTP, time delays in managing all that, putting stuff on a thumb drive and carrying it around. So that's a good little trick that is quite handy when you know about it. Now this one you may also know about, but there's a an option here that I kind of bundle into the whole idea that there used to be a day when everyone who's doing these control systems had a control room and there were people sitting at the control room desk all the time. That tends to be less so right now. There may be a control room, but they're not sitting at the desk watching the control panel. They're doing other stuff. They're on the other side of the room often doing other things. Whether it's filling out reports, they're not sitting directly in front of the computer. So there's a set of features which are basically centered around the idea that I need to be able to glance across the room or be in the same room and know that there's something going on just by looking across the room rather than having to walk up to the machine. So the alarm flasher is one of those pieces. So I'm going to go look at properties again. There's some basic properties under alarms that are just useful to walk through. So number 1, flash the title bar red when there's an unacknowledged alarm. If I turn that on and I create an alarm, this is what I was trying to get ready. I have a little device here that I have real I/O connected to, but couldn't get that going before the presentation. So I know if I put this up to 87 degrees, I will get an alarm. I forgot to hit the apply button here. Thank you. So all the changes take effect. At the top now, I'm across the room. I see that title bar up there which says IoT. It's flashing red. Makes it easier for me to know that there's something going on. So, nice, easy piece. So next piece I want to show you on a similar vein is we can use the alarm priority color for the text. Let's go look at the alarm list right now. It's already flashing orange for that alarm, but I think you can also change the, let's acknowledge this one for a moment. This is another across the room feature, so that's not readable by anybody that doesn't have their nose up against the screen. So at least we could bump it up a couple of notches to help out a little bit in reading that from far away. So obviously the text size is adjustable. So I want to change the current value. I don't think I can do it from here, but put it back to, well, I'm going to leave that there for the moment. I'm going to go back and change this other parameter. That's a different option. I said, make the alarm color match the priority color. So I may not be able to read the text, but from across the room, I can now see that there's an orange alarm on there versus just black text. Helps me to identify the priority of the alarms from far away. Or another way to look at it is I can do a quick glance and see what my status is across on my alarm system. This is one that's not frequently used, but it's an interesting one. All right, so this other really neat feature in here called speak alarms instead of playing sounds. In order to set that, or in order to make that work, you have to also go set up your alarm priorities. So we have a high alarm here for this particular one. And under sounds, so this is alarm priority tags that control the color and the sounds of each alarm category that you have. So this high alarm has this alarm priority tag, and it normally plays a tone, just the typical two-tone alternating sound, or you can alternately play a wave file that could be just like a ringtone kind of thing. But there's a checkbox right here that enables the alarm speech, and that you only get access to that when you've set this speak alarms instead of playing sounds. Little checkbox here. If I apply that change, and then I go edit this particular tag again, under sounds, this box is now no longer grayed out. I can choose what to enable a speech sound. So what happens when this high priority alarm comes in, instead of playing those tones, it's going to actually speak the alarm. Hopefully the audio levels are good here. And it'll speak it 3 times so that you can actually hear it, catches you by surprise. So I'll say, let's just play it twice for now. So I'm going to trigger this alarm. I'm going to change its value back to normal. And then I'll have to go to the page. I'm going to change it back up to a high alarm level.
Orlando, Embassy Suites ballroom temperature high. Orlando, Embassy Suites ballroom temperature high.
So that's the audio output. Now, there's a bit of a story I've got that's kind of similar to this, but the alarm's going off in the room is good because now you don't have to walk across the room. You can hear it. At Ontario Power many years ago, we had something similar set up to this, and they had the speaker system for VTScada plugged into the plant PA system. And the idea is that when the guys are out walking the plant, they could hear the alarms, so they know there's something going on. So there's a guy in the control room, someone out walking in the plant, and he hears this ping, 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 ping. He's like, what's going on? And he goes back to the control room, and the operator's playing pinball on VTScada. He did, and he didn't know that because he didn't hear the PA system in the control room. That was all out in the plant. So there is a, don't Skype when you're on on that kind of thing. Anyway, it does have its use. Sometimes people will find this annoying, but I think Sarasota in Florida here was the first one to want that, so that they didn't have to walk over to the machine to see what was going on. They could actually just listen and know whether it's important, because sometimes configuration of alarms, I think Alan Hudson is going to do a talk on optimizing the way you configure your alarms to get rid of nuisance things, but nevertheless, there are lots of times when there are so many alarms coming in that just walking over every 10 minutes to see what's going on is just a distraction from reality, and being able to hear it is a help to your day. So that's a different kind of feature. The last one here that I want to show you on the alarms is the auto navigation. Again, this kind of goes back to making it easier to run your system without being directly in front of it, or sometimes even when you are directly in front of the system. So there's this feature in here, automatic page navigation. Now this sounds like a real nuisance, and it can be, but I'm going to show you how it would work in an ideal situation. So if we're looking at, I'm going to close this off, say you leave your system up on your dashboard page. You're just watching this for some reason. It's on across the room. It's a nice big page. I can see what's going on. And then suddenly an alarm goes off, and I want to know a little bit more about it than just hearing what's going on. I haven't touched the screen for a while. I enable this automatic page navigation when an alarm triggers. So what will happen here is when you stop touching the keyboard or the mouse for a while and an alarm comes in, it will automatically switch the page on the monitor to a page that contains the information related to that alarm. So right now that's defaulting to 5 minutes. It's not going to be much help for our demo here, so I'm going to drop that down to 10 or 5 seconds just so it makes it easier. I'm going to apply those changes. Now normally you had a little switch on the outside I could throw. It would make it easier for the alarm to generate, but what I'm going to do is just set the manual data for my tag here, which is a little harder to find now. I'll just where are we? MQTT. So I don't want to be on that page, so I'm navigating here just to fake some data coming in, put it back to normal, and then I'm going to put it into the alarm state again. It's going to get very hot in here at 96 degrees. So ideally, I'd just kind of wait here for the, this is going to be
Orlando, Embassy Suites ballroom temperature high. Orlando, Embassy Suites ballroom temperature high.
So this is, what I did was change the alarm, trigger the alarm. When that alarm triggered, it automatically navigated to the page that had that alarm indication of that data on that page. So that's just a help. The other place that might be useful, aside from someone sitting across the room and glancing at the page, would be the system's just so complicated they can't even remember where to go without thinking about it for a few minutes. If it just takes them right there, it just gets you there faster, figuring out what to do. Now, of course, that could be a real nuisance if you're actually actively working on it, and that's why there's this timeout. So if you're actively touching the mouse on a page or using the keyboard, for a period of time after you do that, it won't auto-navigate. So by default, that sets to 5 minutes. So if you're using the system in the last 5 minutes, it won't auto-navigate to the page, but if not, it will take you there. Now, in a similar way, if you're already on the alarm page, it won't navigate you away from the alarm page to show you the data. It'll actually just leave you on the alarm page. There's a feature on this alarm as well that if you use the right mouse button, you can actually say go to page from here. So I say go to page, and then there are actually 3 pages with that information on it. I'll pick which one I want to go to, and it will take me there. So if you're actually on an alarm page, to find out where that data is shown is easy enough to navigate from the alarm page. So that's my alarm tips and tricks. Switching off into another vein entirely, we've got the VTScada repository that stores all of the configuration information for VTScada. It's a great tool. Any configuration changes that get put into the repository automatically get distributed to all of the other computers that have been configured. And if your computer is not connected at the time that the change is made and distributed, when you connect your computer again, whether it's an hour later or a month later, all those changes will come to your computer. It's a great way to keep everything in sync. There are times when your system integrator or tech support, I'll go back to that use case again. If you work on the system remotely, which I've done for customers, you work on your system, you send them a change set, those changes get compiled. If you connect to their system, go back to the hotel, do some work, come back, connect again. All the customers' changes come to you, all your changes go to the customers. That's great. But there's another interesting trick you can play with this repository. It not only stores configuration, it basically stores files of any kind. All the configuration information is stored in files. So we look at your application. We've got a lot of windows open now. Close off a few here. So I have all this installed in a VTScada installation directory. That's obscurely called VTScadaFest 2019 in an application called VTScadaFest. So if I open up my application folder, you'll see that there are many files. Now I know you can't necessarily read those, but I can perhaps take a picture file. Let's say I have a nice photograph I want to use, or something like that. It's got nothing to do with the product, but let's say or perhaps more importantly, I have something like a CAD drawing. It's not going to be used in VTScada. Or maybe it's a PLC configuration file. So I got my PLC configuration file and I dump it into the VTScada directory. I'm just going to use the photographs here as a sort of a proxy for any kind of ancillary file that isn't directly related to your project or your VTScada configuration. I'm going to find out where I am. I'm just going to drop that in here. So my image dropped in there. Go back to VTScada for a second. I'm going to acknowledge my alarm to stop my flashing from distracting me. If I go open up, go back to the application manager here. This is where I normally do it anyway. It says import file changes. So this is my VTScadaFest application that I'm running. Import file changes. And it finds 2 files that are not currently part of the repository. And you get a choice whether you want to add those or not. I've got a spreadsheet and I've got an image file. Also, I'm just going to throw that image file in there. And when I put it into the repository, it's now a file that's part of my repository, goes into every change set, gets distributed to every machine. So as soon as I put that in there, it's now on every computer in your application. If this computer dies, it's still out there somewhere else that you can recover from it. So you can imagine putting your PLC applications in your directory, import file changes whenever it changes. So not only are they distributed automatically, they're so therefore being backed up. You have multiple revisions. So every time you make a revision to that file, it goes through the change log, and you can see every revision that's happened to that file over time. So there's a secondary use to the repository aside from storing VTScada configuration. You could store a set of images of what the station looked like every July 1st or something of that sort. So another way to keep stuff around, the more files you put in the repository and the more revisions you make, however, just be aware it just increases the size of the repository. Not that it's a big problem. Bigger repositories make bigger change sets, which are slower, but operationally it doesn't slow your system down at all. So it's the same speed no matter how many files or how big your repository gets. So it's a really cool way to take advantage of the distributed version control already built into VTScada. So another way, if you send the change set off to your system integrator or they send one back to you, it can contain all your PLC files at the same time. That's right from the VTScada information. Or CAD drawings is another great one to throw in there. View-only workstations. This is one that comes up occasionally. There's a setting that you can add in the advanced options. Font's not too bad there, but read-only station it's called. Read-only station is just a setting, and I'll show you where to find it. Allows you to set up a computer to be well, read-only would be the quick term, but it's not capable of writing any controls to the outputs anywhere in the system. So it basically makes that computer a non-control computer. It's a view-only computer once you set this setting in that computer for this particular application. So I go to my Edit Properties tab in my configuration, up top here. This is the basic mode where we've got nice little check boxes. But that particular setting is an advanced setting. It doesn't show up in any checkbox, and there are thousands of advanced settings, so I'm going to highlight a couple. There's one, the one we're looking for is read. I'll look for anything that starts with read. Oh, mistyped. So I said there's a read-only. Where are we? Yeah, this one's even more obscure. Just remember now, it's not even on the list, so you have to insert one called read-only station. So read-only station, if you set its value to 1, the station that's set on will no longer be able to write. It's basically a security feature. Really important on that one is that this option here called workstation, don't leave it to default, because what that will do is distribute this control to all the computers, and all of your computers will be read-only and have no control from anywhere. So, little caution here, security can hurt sometimes. You have no control. Nobody can hurt your system, not even you. Nobody can help your system, not even you. So this is a really important setting. Get this workstation done. You choose which computer you want to restrict, and I'll say I'm going to restrict this particular computer, Glen Wadden, put a comment on it, say okay, apply the changes, and now this computer is no longer to do any controls on any driver and that from this computer. No matter whether this computer is an I/O server or it's remote. Any controls that initiated from here just go nowhere, do nothing. So You say, why do I want that? Well, you can start to imagine why you might want that. My first use case of that is called a DMZ. So sometimes I might want to have a computer out on the floor somewhere that I say, well, I want people to be able to see what's going on, but I don't want this users coming up and operating things from that computer. But more likely, I want to have remote access from home or on the internet, but I'm kind of nervous about giving any remote control to that in case someone has, breaks the security, discovers a password, logs into the system, and starts doing some nasty things to my plant. So one of the ways you manage that is to put one computer designated for remote access on the internet client, such that when you turn that computer into a read-only workstation. And this restricts, the good guys from not being able to do any remote control as well, but it gives you that extra level of security should you want it. And the next level is to create what we call a DMZ, a section or a computer that's outside your normal firewall of your plant. And Graham's probably discussed this in cybersecurity talk yesterday morning. This DMZ is a computer that you can assume that perhaps this one is going to get compromised by some hack because it's now out on the internet. I can get into it from remote access. And that's its whole point. I need to get remote access to the system. You put basically a machine that I need to be able to get at that. So remotely, but if it catches on fire, it's not going to destroy my plant. The DMZ's philosophy is that the computer in the DMZ cannot initiate a connection into the plant at all. It's a one-way connection. It's only from the plant outward. So the plant makes a connection to your DMZ machine as a backup server. Data flows to that machine, and it can deliver screens, history, and all sorts of information to your clients that are home or working remotely at a different plant. But if it gets hacked, nothing gets destroyed in the plant. So if you make that a read-only workstation, it just allows you to amp up the security level on that system. But it also restricts what you can do remotely. So use that at your own discretion, whatever your comfort level is. I'm going to step up into a different topic that comes up often enough. It's not too uncommon. We get systems where there are multiple facilities separated by a network link. And the network link, if the network link is nice and fast, there's no issue. But sometimes these network links aren't exactly as good as in the plant. Now we have what we call hosted systems or cloud systems where you have geo redundancy. So literally we'll have a server in New Jersey and another one in Nova Scotia so that they don't, a storm comes through or disaster strikes, one server is still running for your cloud-based system. In that kind of scenario, and a lot of citywide scenarios, the link between the two servers isn't as strong as the, sitting on the same desktop. The bandwidth isn't there. So in bigger systems and plants, you have this scenario sometimes where you have a server and you have multiple backup servers or clients that need that data that are at a different site. What I've shown here is you've got a slow link and you've got 3 workstations all trying to access that server across this slow link. So you have 3 data streams going through. So you're trying to push 3 data streams through that slow link. There's another system or another option that we call client of client. It's our term for it. But we can configure in VTScada, instead of the server going like that, we can have the data flowing to one of the workstations remotely, and from that workstation flow to 2 or as many other workstations at that site. So the right-hand side has a fast link within the plants. And the data only has to flow once between the plants. There's a small delay between when it passes through workstation 1, but typically we're talking less than a second. So it's pretty fast. Everyone working on the various workstations really see no difference in the operation, except that perhaps it's even faster because the data isn't being bottlenecked by having to push 3 times the data through that slow link. And now you have only one link going from one plant to the other. And then you say, well, that's a weak link as far as if what happens when workstation 1 fails. Well, then you make the backup server for workstation 2 back out to server. So let's take a look at how you configure that. So the server list basically show you, I wish I could make that bigger for you, but the primary server's at the top, backup server's next, third level server's there. I've got 7 servers, I think, on that list that show you the failover system for all of the services. That's your basic configuration. If I go to an advanced mode, I can make some more sort of interesting configurations. So by default, this is the configuration that we have. And I'm looking at an advanced view. It says the server list for the default servers is these workstations. These computers in that order are going to handle all the activities for our services right now. But I need to make a special case here. So I'm going to create my server list. I'm going to add a service specific list. So for a known service, my MQTT connection, that's a particular driver that I have installed that was for this device, which I hope to demonstrate later on this afternoon for IoT, Internet of Things. I'm going to add a workstation or default server list. So I'm going to add a default, or I'm going to add a workstation specific, here we go. For a workstation specific. So I say that Alan's PC is going to have a specific server list. So think of Alan as being the workstation 2. Well, actually, why don't I just make it explicitly workstation 2 to make it a little clearer for those that get to see this on a screen capture later on in a video. So instead of that, I'll say WKSTA2 is going to have a unique server list. Let me remove Alan here. So workstation 2, you see here on the right hand side, workstation 2 at the top, its server shouldn't be server. It should be workstation 1. So when it's running, its server should be workstation 1. So I'm going to just set that up, and workstation 2, primary server is workstation 1. Great, so only for this particular workstation 2 will it have workstation 1 as its primary server. And then its backup server will be, not sever, but server. Computers don't mind if you spell things wrong, by the way. So, I've got all kinds of issues where, why isn't this working? And you find you made a typo in something. So workstation 2 now will go to workstation 1, which is the local computer. If that workstation 1 is not available, it'll go across this slow link and get your data from the main server across the slow link. And you can set up the same link or the same server list for workstation 3. And it would then, for those particular workstations, they would have a different server list or a different priority of where they get their data for that particular device anyway. So that allows you to do what we call a client of client scenario. So this client of client idea is a very powerful thing. It comes up often. I've seen some utilities in Florida here that could readily take advantage of that, where they have perhaps dozens of remote locations all running VTScada, and they're all connecting into one common server, and that common server is just trying to push out data on a wide area network that's running fairly slowly, and you can see the communication links backing up, where realistically they could cut that load down by a factor of 10 fairly easily by routing stuff through different lists. So we have this next thing which you may know of, but it's also a really powerful thing when you get into a larger system. So I go look at my basic properties. Top check box on there says automatically deploy local changes, and that's one that is, when you install a brand new application, it is on by default. And what that does is when you make a change on a computer, that change automatically gets distributed to all the other computers on the system. Not only that, it gets active on all the other computers on the system. So if you make a page change and you're editing a page, and as you're editing the page, the operator is seeing all the changes that you're making on the page as they're being edited. There's another alternative, which we call the manual deploy. If I turn that option off, now the changes won't be distributed. Well, the changes will be distributed, but they won't become active on the remote stations until you hit this button called deploy. So let's go back to a simple screen here. I'm going to open up our Idea Studio. I'm going to say something simple. I'm going to change that text from IoT sensor to room temp. So I made a simple text change. Changes to room temp. But very subtly, and you may not have noticed, there's this little icon that appears at the top. It looks like a pair of computers when you look at it, or a stack of computers. And the tooltip here says application changes that are not yet deployed, or the application has changes which are not yet deployed, which means that they're visible on this computer. They've actually been sent to the other computers, but they've not been activated. So if I look at my change history, there's a subtle change here on this one. It says my computer name with a dash L and a number. The L means it's a local change. It's an L meaning local change. All the other revisions before that are D, meaning they're deployed changes. They're actually active on all other workstations. So it means that this computer has a local change to that text. Every other machine has that local change, but they're not part of their, what we call it, their active configuration. And it won't become part of their active configuration until this is deployed. Now, this is one of those things that can get a little bit confusing for some people. They think, why don't I see my changes out there? So that's why we go to the auto deploy mode by default, because it's a little more advanced. But it does avoid the issues of somebody making changes and configuring things and interrupting operations until you're sure that it's right. When I go hit the deploy button, there is a button at the top of the page that says deploy. I click on this, and it has now pushed those changes out. Well, the changes are also out, but it's also told everyone else and all the computers in the network to say, use those changes. So it's not just that one computer can make local changes. You could have 3 or 4 or 5, any number of different system integrators, engineers in your plant, technicians working on different pages or different parts of the system. They can all be making local changes and deploy them all at different times. And they can go into production when you're satisfied that the changes aren't in a state of flux. Like it can be pretty disruptive to operations if you suddenly decide to reconfigure your driver and then deploy that and oops. One of the reasons why or the main reason why we deploy all the changes we distribute all these changes regardless of whether they're deployed or not. So my changes, although in concept you can think about they only exist on this computer until I say send them out, they actually exist everywhere. So just in the odd case, and this is not an unrealistic scenario, that your system integrator or someone is using these local changes and they're working on a lot of changes and they're working on them for a week and they haven't yet deployed them. If they were only existing on that laptop and the system integrator went on holiday for 2 weeks, or the laptop disk failed and you lost it all, you've lost all your work. So the fact that it gets distributed out to everyone else means that's in every other repository, and I can go to a different machine and say, those changes he's been working on, I want to take them, put them into production, regardless of the fact that that machine is no longer available. So another obscure feature, it's one that can catch you. Reason why we made it auto deploy by default rather than manual deploy by default was that earlier on, when we first introduced this in version 10, you'd walk into plants and you say, this machine's working fine, that machine is not working fine. It's that people would forget to deploy the changes. So it would be so easy to make a change. You think, oh yeah, it's all working now, I'm good. And forgetting that that change hasn't been pushed out to anybody else yet. And they'll be complaining about, it's not working for me. And that's just because this manual deploy method does take a little bit of forethought. But it's a great tool for managing larger applications. I'm getting down to my end of my presentation, so some of it's a little bit of how-tos on a few things, but there's a few tips, I guess, that are not directly related to configuration, but are really important for you to know. Here's a tip, and don't shut down VTScada by going to the task manager. It's so tempting to do that. So tempting to go down to VTScada because it takes sometimes VTScada, 30 seconds or a minute to shut down. And the reason why it takes that long to shut down is it's writing all of your historical data and configuration out to the disk. And if you shut it down, you're losing that history. And you're losing that configuration change that might have happened. It's non-destructive. It's always writing stuff down so that it's always in order. But when you start back up again, it knows that it's been shut down hard. And then it has to go back and rebuild files. So you're going to pay for it worse coming back online. So it's going to take a longer time to recover coming back online if you shut it down fast. So I'm going to save some time. Just go to Task Manager, kill it. When you come back online, you're going to pay for it like double or triple the time to recover. Because it has to now do this. It's been shut down. I have to scan all the historian stuff, make sure it's all consistent, repair it all. And it will recover, no problem. It's just that you may have lost some data and it'll take longer to recover. Similar to the power switch, we had one customer that had the habit of shutting down the computer at night, and that they just they shut down the computer at night. Or similar ones that would have issues with running a generator test every Tuesday or every second Tuesday. And they do that by doing, they just pull the main breaker, all the control room computers would go down. It's a reasonable test. They all come back up again, but that would be the same kind of problem. You may have lost a little bit of data by doing that. The lesson there is use a UPS if you're going to do that kind of thing. You'll see an icon that normally doesn't show up at the top. This icon, a little battery icon, it tells you what you're running on battery power. I'm running my laptop on battery power now. It shows you how much battery life is left. So you're running a UPS that's connected into the operating system. The operating system now knows how much battery life is in that UPS. VTScada now knows how much battery life is in that UPS. There's a setting in VTScada, it's typically at, I think, 10%. When you get down to 10%, it will automatically shut down VTScada and do this orderly shutdown, saving all your history rather than doing that hard shutdown when you run out of battery life. So if you hover over this battery icon, it'll tell you how much battery life you have remaining, estimated at your current power usage. This one is useful. You probably already know this, but when you're polling I/O, it's really easy to use the default polling rates of 1 second. If you use 1 second polling rate, everything works fine until you get into 50,000 I/O and the data is changing a lot. You end up recording a lot of data, moving a lot of data around, and it's starting to impact the performance of your system. So there are deadbands by default in the system now, small deadbands. So I encourage you to use those deadbands where it makes sense. Every analog signal, every analog instrument that you have out in the field will have this noise on the signal. It's just inherent in the way these 4 to 20 milliamp signals work. There's just a little bit of noise that's always fluctuating. It means nothing because it's right down in the 0.1% kind of range. It's not, it's just electrical noise in the background. All that noise gets recorded. You put a little bit of deadband in and say, I don't want to record anything that's more than 0.25% or some significant number. Says, unless it's changed by a certain amount, I don't really want to overload the system by looking at that. So that 1 second poll rate too, you have to ask yourself, do I really need to see that data every second? Am I okay with seeing it every 10 seconds? 10 seconds means your system can be 10 times bigger for the same computer capacity. That makes a big difference. Some data you don't need to see that often. If it's a tank level, how fast can it really move? Well, you better hope it doesn't move that fast. And if you don't see it, does it make much difference if you see it 10 seconds later or not? Other things you probably do want to see it because you need to know there's some high-speed machinery that having high resolution history on it is valuable. That's good. That's good. I've had one of our customers out of California that runs monitoring on GE gas turbines, and there are turbines, as he says. I'm sure it's the American way. They are, high-speed rotating machinery, highly dynamic. They're basically jet engines running generators, and they record their data every 1/10 of a second, because when things go wrong, they go wrong fast, and they want to see how things go off. If something gets out of balance, things start to go wobble within a few seconds, and it shuts down, and they want to know everything that happened right up. What went wrong first, and exactly what was the sequence of events that led to that. And there's a good case to go fast. A lot of times in water system, things don't really move that fast, and slower update rates are perfectly good and will make your response time to operators much better if you can actually afford to say, well, 1 second, yeah, that's good. 10 seconds is too long. Maybe 2 seconds is better in the plant. 2 seconds means, again, double the capacity in your plant versus 1 second. So I'll make the pitch there. This one is an interesting one that we came across a few months ago. There are some vulnerabilities that were announced about a year ago from, I think, Google and someone else. There are 2 vulnerabilities that are referred to as Spectre and Meltdown. We'll go into, you can Google them. There are inherent vulnerabilities in the way modern microprocessors are implemented that could theoretically allow a program on your machine to see data in another program on the machine. And if you take that to the extreme, it says maybe the program could snoop in on operational data, maybe it could snoop in on your password when you're typing into the website. So potentially nasty, and I say potentially because I don't believe there are any known hacks that actually use this. These are really tough things to actually make happen. So they're theoretical. There are some, but reason why I bring them up is that there's some patches that have gone out in Microsoft Windows that try to shut down those vulnerabilities. That sounds great. There's a side effect of those shutdowns in that the Windows systems run really slowly after those patches are applied. And we see that sometimes startup times for VTScada, and it particularly affects file I/O, can double because of the patches that have been applied. So you got to look at, okay, first of all, there has to be some malware getting onto your machine. It has to have intimate knowledge of how VTScada works. And not just that, actually how it's loaded into memory right now to exploit this thing. And there's no known exploits that actually take advantage of this. So yes, if you're paranoid, take advantage of it. If you're already defining good firewalls, these patches could cost you performance. But there's a way to turn them off. Your choice, but there's this downloadable application. Nice to play this nice beep when it comes up. This little app called Inspector. Notice how the way it spells RE at the end to match the vulnerability. So this tells you whether the patches have been applied and allows you to turn off those patches if you want to. One of the characteristics of these patches is that the older your processor is, the less support in the hardware for patching it. So there's more software level patches have to be applied, and it more severely affects the performance of the processor. So if you're running an older machine by a few years, these Spectre meltdown patches that kind of crept in around summertime will affect your machine more severely. So yeah, absolutely great to absolutely need to keep updated on Windows patches, but this is one that kind of made us worry, saying, why does suddenly everything going slowly? We run automated tests. We have this continuous automated build process that allows us to, every time a change is made to the software, it goes into our machine. We call it the CAB. CAB meaning continuous automated build. And all of a sudden, CAB tests started failing because we have performance tests built into them and saying, why suddenly? Just suddenly the CAB tests starting to fail on things that we didn't make any code changes to. Eventually, after a few days, tacked it down to there's something happened to the Windows patches that kind of has had an impact. And it's a good case for why we do these automated tests. So you can actually, with this tool, change which patch you want to apply. Now, Spectre is the one that seems to have the biggest impact. So you can, and I've chosen to disable that because I love performance. I'm running virus protection on machine. I always hide behind firewalls. I'm comfortable with it. I have backups of everything. You may not be as comfortable in a production environment. Your choice. You just have to know about it. So it may be something that's going to affect you. And it probably will. One of these things in a hosted environment or a cloud environment, these are patches to the firmware of the microcode of the processor. So if you're in a cloud environment, you might get affected by it, not because your virtual machine has done anything, it's because the host environment has changed the processor. So they updated the firmware on the processor, and you've kept your machine rock solid on a virtual machine, but it's the underlying system that's a problem. On the other hand, virtual environments, because you're sharing the processor across multiple virtual machines, this exploit theoretically would allow you to, on one virtual machine, get at data in another virtual machine on the same box. And I say, that's scary. You think virtual machines kind of in complete isolation, this exploit could allow you to get past that. Anyway, scary stuff. Anyway, that's it for my presentation today. I'll invite questions if anybody has any questions.